By the UN, a full 2/3 of the world will live in water-scarce regions by 2025, which could displace as many as 700 million people.
Sallallahu Alaihi Wasallam says that 3 years before he appears there will be a famine. In the first year, the heaven, there will be a third less rain in comparison with the years before. And the earth, there will be a third less crops in comparison with the years before. In the second year, the heaven will withhold 2/3 of its rain, and the earth 2/3 of its crops. In the third year, the heaven will withhold all of its rain, and the earth all of its crops. There will not be a single drop of rain on the earth, and there will not be a...
Around the world, water is constantly moving. From 2002 to 2016, a pair of NASA satellites witnessed massive shifts in the freshwater stored on land, related to water management, climate change, and natural cycles. The Gravity Recovery and Climate Experiment, or GRACE mission, used precise measurements of the motions of 2 spacecraft in Earth's orbit to track the movement of water through the oceans, land, and atmosphere. NASA scientists combined GRACE data with satellite-based observations of precipitation and crop irrigation, climate model predictions, and other information in order to identify the causes of regional trends in freshwater storage. In this visualization, blues indicate areas with more stored freshwater than the average, and oranges and reds denote areas with less. The science team classified the major trends observed by GRACE as driven by natural variability, human activity, or climate change. For instance, the steady decrease in freshwater storage in Greenland is caused by the melting of glaciers, which drain water into the oceans. In the western United States, a long drought reduced mountain snowpack and river flows, causing heavy reliance on aquifers for crop irrigation and severe depletion of freshwater resources. Precipitation measurements together with GRACE data show how natural variations in the weather and unsustainable rates of water use conspired to deplete groundwater in California. In southern Africa, the Okavango Delta region experienced a huge increase in stored freshwater during the period of the GRACE mission. The science team analyzed precipitation data for the area and found that it was caused by a pronounced increase in rainfall. Between 2004 and 2012, the region saw about 15% more annual rainfall than during the previous 25 years. The rain ended a regional drought and replenished water storage in the area. In northern Saudi Arabia, GRACE detected a dramatic decrease in freshwater stored in aquifers. Images taken by NASA's Landsat program show a rapid increase in irrigated cropland, supported by water pumped from those aquifers. Most of that water is non-renewable on human timescales, but in 2014, the Saudi government ended a domestic wheat farming program, and GRACE data suggests that aquifer levels may be stabilizing. In northwest China, GRACE revealed a rapid decrease in freshwater storage without an obvious cause. Scientists knew that mountain glaciers were melting, but the meltwater did not leave the region, so they looked for another explanation. As it turns out, much of the region's surface water is redirected to agricultural areas and the desert to the south, where it evaporates, leaving the region with a net loss of water. The original GRACE satellites stopped operating in 2017, but NASA and the German Research Center for Geosciences are partnering to launch a new satellite pair, GRACE Follow-On, in late spring 2018, to continue providing data about freshwater trends around the world.